All right, we have a system of linear equations and we are being asked to solve it by graphing. Now, when you solve a system of equations by graphing, you have to graph two, sometimes more, but usually just two equations and find out where the lines intersect. So let's graph one at a time. I'll graph you by saying, all right, well, you are already in slope-intercept form, like so, where my slope in this case is negative 5 over 3 because when y is all by itself, the number in front of x is my slope. And my y-intercept, the number floating around, is going to be 3. So when you graph this guy, you start out by placing your dot on the y-intercept, and since this is a negative slope, you go up 5, left 3, up 5, left 3. Well, I can't go up 5, left 3, so I'll go down 1, 2, 3, 4, 5, right 1, 2, 3, and put a dot there. Now I can't do it again, so I only have 2 dots, and that's perfectly fine. So you take your line and draw it out. I'm going to use this because I'm awful at drawing lines, and this does the job just fine for me. All right, so that's my first equation. Now let's graph the second. Again, this is in slope-intercept form already. That makes life a whole lot easier. So my slope in this case, the number in front of x when y is all by itself, is going to be 1/3. And the number floating around when y is all by itself is my y-intercept. And that in this case is negative 3. So we'll put a dot at negative 3. The slope is 1/3, which is positive, so up 1, right 3, up 1, right 3, and we already have that dot right there that intersects. I can't go up 1, right 3, but I can go down 1, left 3 if I want to, just to get more dots in. We take our line, we graph our line, best to our ability, if I know what I'm doing here, and then you can see that those lines intersect at that specific point right there where both the red and the blue meet. Now that point right there is 3, negative 2. What this means is that if I were to call you x and if I were to call you y and replace y with negative 2 and replace x with positive 3 and do a little bit of math, it'll be true for both of these cases. That is the solution to a system of equations. What xy value, what x and y pairing is going to be an answer for both of these at the same time. And so when we graph them, we can find our answer where the lines intersect. And that's how you do it. Solve this system by graphing. We are going to take both of these equations and graph them on the same coordinate plane. When I graph them, I'm going to have two lines, and wherever they intersect is going to be my solution. So first things first, let's compare both of these to y equals mx plus b. These are both in slope-intercept form. So this first guy has a slope of 4 and a y-intercept of positive 3. Remember, when y is all by itself, the number in front of x is my slope, and the number floating around is my y-intercept. Now, slope of 4 doesn't look right. I'm going to make it 4 over 1. Now, I'm going to graph this line first. I'm going to start out by putting a dot at 3 on the y-axis because that's my y-intercept. Since this is a positive slope, it goes up and to the right. So up 4, right 1. Well, I can't go up 4, right 1. I ran out of space. But I can go down 1, 2, 3, 4, left 1. Down 1, 2, 3, 4, left 1. And I have 3 dots there, and that's more than enough to draw a straight line. So let me do that. Let me pull one of these lines out. If I can actually hit the right buttons, you'll see a bunch of red dots there because I hit the wrong button. That's all right. That's all right. And there you have your first line. Okay. Now let's graph the second line, and we'll do that by saying that this is a slope of negative invisible 1. Remember, when y is all by itself, the number in front of slope is, the number in front of x is my slope. That's an invisible 1. So my slope is negative 1 over 1 because I want to turn it into a fraction. My y-intercept is negative 2. because that negative is included with the b. Positive b is going to equal -2, so my y-intercept is -2. So we're going to start graphing this guy by putting a dot at -2 on the y-axis. This is a negative slope, which is down and to the right or up and to the left. So down one, right one, down one, right one, down one, right one. When you run out of space, you can go up one, left one, and you can see where my two lines are going to intersect already. So let's grab our line. Let's draw our line like that. And you can see that these guys intersect at this point where where the red and the blue meet. Now that point is going to be -1, -1. Now what this means is if I were to label you X and Y and replace every Y with -1 and replace every X with -1, this would give me a true statement for both of these. That is what a solution is. A solution to a system of equations is where both you're given an X and a Y value that makes both of these true. And the way you can figure that out is if you're given stuff in slope-intercept form, you can just graph them. And hopefully the answers are nice. And in this case, they are. You get -1, -1, and that's going to be your guy. Solve this system by graphing. I'm given two equations in slope-intercept form. When y is all by itself, the number in front of x is my slope, and the number floating around is my y-intercept. Now, I'm going to graph this guy first by noticing that my slope is -2. But you know what? I'm going to write that as -2/1 because I want to think rise over run thoughts. And my y-intercept is +2. So the way we graph this is we put a dot on our y-axis where our y-intercept would be. You go up 2, left 1, up 2, left 1, because it's a negative slope. Or you can go down 2, right 1. Either way, that gives us more than enough points to draw ourselves a nice little line. So let's draw our line connecting all those red points right there, all those red dots. And we have line number 1 drawn out. Now, in order to solve this system of equations, we care about where these lines intersect. So let's graph this second one. Okay, y is all by itself. The number in front of x is the slope, so the slope is also -2/1. That's interesting. My y-intercept is going to be -2. So I'll put a dot at -2, like that. My slope is -2/1, so I'll go up 2, left 1, up 2, left 1, up 2, left 1. Ran out of space, so I'll go down 2, right 1, and I'll draw the lines. And remember what I said, the solution to a system of equations is where the lines intersect. These lines are never going to intersect. Why? Well, because they have the same slope. And if you have two lines with the same slope and different y-intercepts, they're parallel lines. Parallel lines are never going to intersect. So what's my solution? Well, I have no solution. And what that means is usually when you have a system of equations by graphing, you're supposed to get a point. You're supposed to get an xy value. And that xy value would say if I plug in the x value into both of these and the y value into both of these, it's going to make both of these work. Well, there is no point that's going to make both of these work, which means I have no solution. So again, if you notice right away, like I didn't even have to do anything if I didn't want to. I knew right away that these are going to be parallel lines. If you know they're going to be parallel lines, you're going to have no solution. Now, for some reason, you have a problem where the same line, well, that's an infinite solution, but we didn't have that here. Since these are parallel, it's no solution, and that's our guide. We're done. Solve the system by graphing. A system of equations, when graphed, is going to intersect somewhere. And if it does intersect somewhere, that's going to give you a point, which is a solution to the system of equations. Now, this first equation right here is not even slope-intercept form. When it's y equals a number, it's just a horizontal line that goes through that number. When it's x equals a number, it's vertical, but this is y equals a number that's going to go through -1. So let me drag down one of these lines and put it through -1 so we could just be done with that guy. Like so. Now this other guy is in slope-intercept form. Remember, slope-intercept form is when y is all by itself, the number in front of x is the slope, and the number floating around is the y-intercept. So in this case, my slope is going to be -5/2, and my y-intercept is going to be 4. So the way you graph that is you put a dot at 4. My slope is negative, which is up and to the left. And so I would go up 5, left 2. Well, I can't go up 5, left 2, but I can go down 1, 2, 3, 4, 5, right 1, 2, put a dot right there. How convenient. Down 1, 2, 3, 4, 5, and I'm out of space already. So now that I have my 2 dots, which is all I need, I'm going to graph this line like so. If I can do a good job, this is very difficult. There we are. And we can see that these 2 lines are going to cross at a point. And that point is going to be 2, -1. Now what 2, -1 means is if I were to label you x and label you y and plug you into both equations, it's going to be a true statement for both. And we can even see that. If you're looking at like, well, if I call you x, how could I plug it into the top equation? You can't. Y is just -1, as we can see. But if you were to take this and replace y with -1 and replace this with x with 2, do a little bit of math, it will give you a true statement and it'll work. So solving a system of equations is for you to getting a point, an xy value that makes both solutions true, or both equations true, and we ended up with 2, -1 in this case. That's it. Solve the system of equations by substitution. When you're solving a system of equations by substitution, the first thing you're going to want to do is take one of your equations and solve it for any variable. Well, that's already done. The first equation is solved for y. So once you have y or x all by itself, you take that equation and plug it into the variable for the other equation. So this is going to be a bit sloppy, so bear with me. Y is 6x minus 11. So I'm going to write the other equation and turn y into parentheses 6x minus 11 because y is 6x minus 11. Okay, so I rewrote this bottom equation and replaced y with 6x minus 11. The rest is just, an ugly math problem. Distribute, that gives us -2x minus 18x plus 33 equals -7. Combine like terms on the left, -2x and -18x make -20x. Drop down plus 33, drop down the equal sign, drop down -7. In order to get x all by itself, we subtract 33 from both sides first, 33 from both sides. That gets us -20x equals -40. In order to get x all by itself one more time, we're going to divide both sides by -20, the inverse, and x is going to equal +2. Now, a system of equations is going to have a solution as a point. So not only do we need an x value, but we need a y value too. How can I find my y value? Well, I know y is 6x minus 11. So why don't I replace x with 2 and say y is 6 times 2 minus 11. So y is going to be 12 minus 11, and y is going to be 1. Now that I have x is 2 and y is 1, I'm going to get myself a point in the format 2, 1. Now, a solution to a system of equations means if I were to label you x and label you y and plug you into both of these, it's going to work for both of these. If you watched my videos on graphing, what we would normally have done is graph both of these and find out where they intersect. Well, I don't want to graph something with a y-intercept of -11, and I don't want to graph something that's not even close to being slope-intercept form. So substitution is a way that we could use to get our point, and our point in this case is 2, 1. Not the easiest thing in the world, but that's how you do it. Solve the system of equations by substitution. When you solve the system of equations by substitution, what you want to do first is make sure one of your equations is solved for either x or y. Well, in this case, y is already -2. So since y is already -2, I'm going to take it to the other equation and replace y with -2. So let me write out that bottom equation, 4x minus 3, but instead of y, I'm going to put parentheses -2 and then finish writing out equals 18. Okay? So do a little bit of math. -3 times -2 is +6. So 4x plus 6 equals 18. Subtract 6 from both sides. Subtract 6 from both sides. 4x equals 12. In order to get x all by itself, you divide both sides by 4. And x is going to equal 3. Now, a solution to a system of equations is a point in the form x, y. I found my x. I didn't find my y yet, except for the fact that up here it tells us y is -2. How convenient. Now that I know y is -2, I can put together a point of 3, -2. And that's my answer. And so what this means is if I were to label u x and label u y and plug it into the top equation and plug it into the bottom equation, it's going to work for both. Okay, even though there's no x up here, y is already -2, so that seems to work out just fine. And if I were to replace that x with 3 and that y with -2, do a little bit of math, I would end up by getting 18 equals 18, which is a true statement, which means my guy is true. This point works for both. I am done. Solve the system of equations by substitution. Whenever you are asked to solve a system of equations by substitution, you start out by making sure one of your equations is either solved for x or y. Well, that's not happening right now. You're not solved for x or y. You're not solved for x or y. These are both in standard form. So what I do is I choose the easiest one to do. And for me, the easiest thing to do would be to take that top equation right there and solve it for y. So I have -5x plus y equals -2. Now, why am I choosing that? Because y has no coefficient. The other guys have coefficients, so y is probably going to be easiest. Now, the way we get y all by itself is we do the opposite of -5x, which is add 5x to both sides. So y is now equal to 5x minus 2. Now I did this by rewriting the top equation. Now that I have the top equation, I'm going to replace the bottom equation by plugging in 5x minus 2 into the y down there. So I'm going to write the bottom equation, -3x plus 6, and instead of y, I'm going to substitute in 5x minus 2. Close the parentheses, equals -12, and we just have a bunch of ugly math right now to deal with. Okay, distributed property, 6 times 5x is 30x. 6 times -2 is -12. Drop down the -3x, drop down the plus sign, drop down the equals, drop down the -12. Now, combine like terms on the left. -3x and 30x make 27x minus 12 equals -12. Now, this is going to be super convenient, and it's going to look like you did something wrong, but you didn't. I have -12 on the left. I also have -12 on the right. So in order to get rid of -12, you add 12 to both sides, and that makes both of you cross out. So 27x is going to equal 0. Divide both sides by 27, divide both sides by 27, and x equals nothing. And you might think, oh, I did something wrong. Nope, you're fine. You didn't do anything wrong. 0 is a number. You're allowed to get 0. Now what I have is just x. X is 0. I need a y. How can I find y? Well, didn't I take the top equation and solve it for y a couple minutes ago? I did. So why don't I take that guy right there and replace x with 0 because x is 0. So y equals 5 times 0 minus 2 is going to give me y equals 0 minus 2, and 0 minus 2 is negative 2. Now that I have an x value of 0 and a y value of negative 2, I can put together a point that is 0, negative 2. Now what this means is if I were to label you x and y and plug that into the top equation, the math is going to turn into negative 2, and negative 2 equals negative 2, making it a true statement. If I were to label you x and y and plug it into the bottom equation, the math is going to end up being negative 12 equals negative 12, and that is also a true statement. The solution to a system of equations is a point in xy form that makes both of these true, and 0, negative 2 does that for us. Not the easiest process in the world, but it works. Solve the system of equations by substitution. In order to solve a system of equations by substitution, you need to have one of your equations already solved for either x or y. Well, that's not the case. But you know what I notice in the bottom equation? Y is positive all alone, all by itself. So if I take this bottom equation and add x to both sides, y is now all alone by itself, and I get y equals x plus 3. Now again, my first step in substitution is to get any equation and solve it for any variable, and since y is positive all by itself, no coefficient, that seems to be the easiest one to use. So I did that. Y is now all by itself. Since I manipulated the bottom equation, I have to plug this into the top equation. So I'm going to rewrite out the top equation, negative 3x plus 3, and replace y with the fact that y equals x plus 3. So I'm going to replace y with x plus 3. I'm going to finish that up by equaling 4. So I rewrote the top equation because I changed the bottom equation and replaced the y with x plus 3. Let's do a little bit of distributive property. 3 times x is 3x. 3 times 3 is 9. Drop down the equals, drop down the 4, drop down the negative 3x, drop down the plus sign. On the left side, I can combine like terms. Negative 3x and 3x cancel out. And that leaves me with 9 equals 4. Well, if my variables cancel out and I'm left with something that doesn't make sense, I'm done. And my answer in this case is no solution. Now, in this problem, if I were to solve both of these for y and graph them, I'm going to end up with parallel lines. And parallel lines don't intersect, which means there's no point where both of these will meet. Both of these guys are never going to meet up anywhere, so there's no solution. This is a special case problem. Now, if we did a problem and it was something like 9 equals 9, that would be the infinitely many solutions part. But since this is 9 equals 4, an incorrect statement, the variables disappeared, I have no solution, I'm done this problem. Solve the system by elimination. Now we've looked at two other methods of solving systems of equations. We did graphing and we did substitution. This is a third method. Now this method is convenient if all of your x's, y's, equal signs, and numbers are lined up. Oh look, they are. It's also convenient if in one of your variables you have the same exact coefficients but one is positive and the other is negative. Oh, look at that. That's the case too. So now we're going to use elimination because this method is faster. Once you have everything stacked up in some type of order, all the x's, y's, equal signs, and answers are all stacked up, and once you have a negative something x and a positive something x, and they're the same, it could be the y's too, you add the rows. So we are going to add negative 4x plus 4x, which cancels out. How nice. Now we have to add the others. Negative 2y plus 8y is 6y. Drop down the equals. Negative 12 minus 24 is negative 36. In order to solve for y, all you have to do is divide both sides by 6, and y equals negative 6. So y is solved for. Now what I have to do is solve for x. I pick any equation I want. I'm going to pick the bottom one because 4x is positive and I prefer positives. Rewrite it out, but replace y with negative 6 because y is negative 6. So 4x plus 8, replace y with negative 6 equals negative 24. 8 times negative 6 is negative 48, and everything just kind of comes along for the ride. Drop down the 4x, drop down the negative 24, and solve for x. Add 48 to both sides, like you normally would a two-step equation. Drop down the 4x. Negative 24 plus 48 is positive 24. Divide both sides by 4. X equals positive 6. Now that x equals positive 6 and y equals negative 6, you have a brand new point of 6, negative 6. Now what this means is this is a solution to a system of equations just like it's been with the other solutions to equations. If I were to label you x and if I were to label you y and plug those in for x and plug those in for y, I would get a true statement for both of these. So if I were to graph these would intersect at negative or 6, negative 6 right there at that point. But I'm not going to do that because who wants to graph these? That's why we have substitution and elimination. And again, elimination is for when things are kind of nicely in order and stacked up perfectly. Solve the system of equations by elimination. Now, whenever you're using elimination, you're going to want to make sure everything is stacked where it wants to be. In this case, it is. The x is on top of the x's, the y is on top of the y's, the equal signs on top of the equal signs, and the numbers on top of the numbers. It doesn't have to be in that order as long as it's stacked in some type of order. But what you're also looking for is you need to pick a letter that has the same coefficient but one's positive and the other one's negative. That's not the case. 5x and 10x are not the same. Y and negative 7y are not the same, but you know what? If I were to multiply the entire top row by negative 2, that would get me negative 10x minus 2y equals negative 18. Then underneath it, I can rewrite regular 10x minus 7y equals negative 18, and I have myself two numbers that are exactly the same. One's positive, one's negative. So once we get to that point, we add the rows. Negative 10x plus 10x crosses out. Negative 2y minus 7y is negative 9y. Drop down the equal sign. Negative 18 minus 18 is negative 36. And now we can solve for y. Divide both sides by negative 9. Divide both sides by negative 9. Y equals positive 4. Now I'm not done. What I have to do is I have to find x, and I can take one of my original equations to find x because I now know that y is 4. I'm going to take the top equation. Why? Because y is kind of all alone all by itself. So why don't I just take this top equation, rewrite the original top equation out, and replace y with positive 4. So 5x plus positive 4 equals 9. Those parentheses aren't necessary. I'm just going to get rid of that 4 by subtracting 4 from both sides, minus 4 minus 4. Drop down 5x, drop down the equal sign, 9 minus 4 is 5. In order to get y, or x in this case all by itself, divide both sides by 5, divide both sides by 5, x equals 1. Y is 4, x is 1. This gives me the point 1, 4. Now, this is the solution to a system of equations. And what you do with the solution to a system of equations and what it actually means is if I were to call you x and call you y and plug you into the original problems, this would give me true statements. So if I did 5 times 1 plus 4, I would get 9. 10 times 1 minus 7 times 4, I would get negative 18. And this is a point, an xy pairing, that gives you true statements for both of these. And that's how you solve a system of equations by elimination when it's not given to you perfectly. Solve the system of equations by elimination. When you're dealing with elimination, the first thing you're going to want to make sure you have is the x's are lined up, the y's are lined up, the equal signs are lined up, and the numbers are lined up, and that's what I have here. What I don't have, though, are the fact that my x's here are different and not opposite, and my x's here are different and not opposite. Or my y's rather. I need my variables, or at least a pair of variables, to be the same but opposite, and that's not the case here. So why don't I take the top equation and multiply it by 2? Actually, -2. And the reason why I'm doing -2 is that'll make that positive 14y, and this will be negative 14y. So by multiplying the top equation by -2, negative 2x is positive 2x. -7 times -2 is positive 14y. 14 times -2 is -28. We're going to rewrite out the bottom equation as is because we don't need to change anything. Now, if you're wondering, sir, why didn't you just multiply the top equation by -4 and eliminate the x's? I could have. You'll get the same answer. I just decided not to do it that way. Leave me alone. Add up the rows. 2x plus -4x is -2x. The y's cancel out. Drop down the equals, and ooh, how nice, -28 and regular 28 also cancel out and become 0. So we have -2x equals 0, divide both sides by -2, divide both sides by -2, and x is going to equal 0. Now that I know x is 0, I can go up here and plug it into any equation I want to get my y. So it doesn't really matter which one I use. I could use the bottom one, who cares? I'm going to rewrite out the bottom equation and substitute 0 for x. So -4 times 0 minus 14y equals 28. Okay, -4 times 0 crosses out. Drop down the -14y equals 28. Divide both sides by -14, and y is going to equal -2. X is 0, y is -2. That gets me an ordered pair of 0, -2. Now what this means is if I were to label you x and label you y, and plug 0 in for x here and plug -2 in for y here, it would all end up being 14. Same thing, if I were to plug that into the bottom equation, it would all end up being 28. So this guy acts as a solution to both of those equations. And I'm done. Solve the system by elimination. What I have here is everything's lined up perfectly. The x's, the y's, the equal signs, the numbers, all lined up perfectly. But what I don't have is I don't have variables that are the same but opposite, the same coefficients but opposite. In fact, not even close. So what I'm going to do is there's no way I could just multiply one line up here to get this line down here unless I want to use fractions, which I don't want to do. What I'm going to do is, since I already have 2x and 5y, I'm going to multiply this top row by 5 and this bottom row by 2. What's going to happen by doing that is x becomes 10x and x becomes -10x, and then I can add the rows and everything will be just fine. So this becomes 10x plus, multiply 5 to everything, 40y equals 30. The bottom row becomes -10x minus 40y equals -30. So I guess what I'll do is I'll add the rows. You cancel out. You cancel out. You cancel out. 0 equals 0. What does that mean? I know what that means. That's infinite solutions. When your variables disappear and you're left with a true statement like 0 equals 0, that's infinite solutions. If my variables were to disappear and I had something like 3 equals 5, that's a no solution. But this one was a whole lot nicer because that's my answer. Well, how nice. Solve the system of equations by elimination. In order to solve a system of equations by elimination, you need to line everything up. I'm not even close. So what I'm going to do is I'm going to put both of these in standard form. I'm going to have x, y equals number. So let's start off with this guy. I'll label you black. 3 plus 2x minus y equals 0. In order to get you to standard form, I'm going to subtract 3 from both sides. Minus 3 minus 3. Drop down to 2x minus y equals negative 3. So now you're in standard form. Let's do this guy. Negative 3 minus 7y equals 10x. Watch what I do. I want this to be something x, something y equals a number. I don't want to move too much. I'm going to add 7y to both sides. And you might be like, no, 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 sir, that's going to be backwards. Watch. Negative 3 equals 10x plus 7y can also be written as 10x plus 7y equals negative 3. Pretty smart, huh? Now that I have everything lined up, I need to eliminate. Well, I can't because 2x and 10x are not the same but opposite, and negative y and 7y are not the same but opposite. So let's get rid of x, and we'll multiply the top row by negative 5. By multiplying the top row by negative 5, and let me write it out here to the left, I'm going to end up with negative 10x plus 5y equals 15. The bottom equation stays the same. 10x plus 7y equals negative 3. If you're wondering, why didn't you just multiply the top by 7 to get rid of the y's? I could have, but I didn't. So I'm going to add these two rows up. I'm going to add them up. That crosses out. This becomes 12y, and this becomes 12. Divide both sides by 12. Divide both sides by 12. And y is going to equal 1. Now you know y is 1. I have these two original equations. I'm going to pick one of my original equations and solve for x by plugging in 1. So why don't I use the bottom equation? To me, it looks less sloppy. If I use the bottom equation, it would be negative 3 minus 7 times 1, because y becomes 1, equals 10x. Okay, negative 7 times 1 is negative 7, so negative 3 minus 7 equals 10x. Negative 3 minus 7 is negative 10 equals 10x. Divide both sides by 10, and x equals negative 1. Now that x is negative 1 and y is positive 1, I have an ordered pair of negative 1, 1. And what that means is if I take negative 1 and plug it into every x here, and take 1 and plug it into every y here, I would have two things that would match up perfectly. So this problem was a mess, but we rearranged it, we did a little bit of multiplication, and we did fine in the end. Ooh, word problems. Find the value of two numbers if their sum is 12 and their difference is 4. So let's just call the two numbers x and y because I like x and y. X plus y equals 12 gives us the equation their sum is 12, and x minus y equals 4 is going to give us the equation for their difference is 4. Now, it's up to me to choose if I want to do substitution, elimination, or graphing. I'm going to use elimination. Why? Because I have a y up here and a negative y here. And if I add these two, the y's cancel out. That gets me x plus x is 2x, y's cancel out, equals 16. Divide both sides by 2, x equals 8. Now that I know that x equals 8, we take one of these original equations, and I'm going to take the top equation because it's a little bit prettier, and solve for y by replacing x with 8. So instead of x, I'm going to have 8 plus y equals 12. I don't need those parentheses. All I have to do is subtract 8 from both sides, and you get y equals 4. So, and rather than answering it and circling it like that, rather than putting it as a point, this is a word problem. So I will say the two numbers are 4 and 8. Now I can check that really easily. 4 plus 8 is 12. 8 minus 4 is 4. Bada bing. Okay, so when you're given a word problem, turn it into a system of equations. Take it from there. Mia and Noah have two types of cats. Good for them. Siamese and Maine Coons, of course, the Maine Coon being my favorite. They decide to buy cat food in bulk for all their cats. Each Siamese cat eats 2 cups of food per day, while each Maine Coon eats 3 cups of food per day. Together, their 12 cats eat 29 cups of food per day. How many Siamese cats and how many Maine Coons do Mia and Noah have? So let's do this. Let's call Siamese X and Maine Coons Y. We're going to come up with 2 equations because we're given 2 pieces of information. Okay, one of the equations that we're going to come up with is how many cups each cat eats and the total amount of cups, and how many cats they have altogether. So let's take a look at the cups part. We've got, they decide to buy cat, blah, 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 each Siamese cat. So X eats 2 cups. So we could say 2x. Maine Coon Y eats 3, so we could say 3y. Together their 12 cats eat 29 cups. So the amount of cups that they eat is going to be 2x plus 3y equals 29. Okay, that's the tricky part, coming up with these equations. Now, what's my other equation going to be? Well, how many cats they have in total. The Siamese cats and the Maine Coon cats add up to 12 cats total. Like that. So what I'm going to do is I'm going to use elimination. Why not? Everything's lined up nicely. I'm going to use elimination. Substitution might be really nice here too, but I'm sticking with elimination. So I'm going to multiply this bottom row by -2. That way I can eliminate my x's. So I have -2x. -2 times +y is -2y equals -2 times +12 is -24. I'm going to rewrite my top equation as 2x plus 3y equals 29. Now this is going to be super convenient because when I add these 2 rows together, yes, they cross out, but 3y minus 2y is 1y, or just y. And y is going to equal 5, so how nice, I'm already there. Now y is 5, I have to find my x, and I'm going to use the green equation down there to do it. So I'm going to rewrite the bottom equation, the green equation, and replace y with 5, like so. I'm going to subtract 5 from both sides, like so, and x is going to equal 7. Now this is a word problem. So I'm not going to say, oh yeah, we have the point 7,5 and circle that. That doesn't make sense. If someone's like, how many cats do you have? You're not going to say 7,5. X here represented Siamese cats. So we're going to say 7 Siamese cats, and we're going to say 5 Maine Coon cats. So that's our guy. So again, the purpose of solving systems of equations word problems is you need to come up with 2 equations based off of the 2 groups of information that you have. Usually one of the equations is going to be total, and the other equation is going to be some type of value or amount. And then you go from there. Hope this helps. Emma runs a small business selling handmade cat toys and cat beds. Good for you, Emma. She sells each cat toy for $10 and each cat bed for $25. The cost to produce each cat toy is $4 and the cost to produce each cat bed is $15. Last month, Emma sold a total of 50 items, cat toys and cat beds combined, and made a profit of $480. How many cat toys and how many cat beds did Emma sell? All right, so we're looking at 2 things, cat toys and cat beds. There's a lot more numbers here than what we're used to. Let's call cat toys X, let's call cat beds Y, okay? Now, let's focus on colors here. Cat toy she sells for $10. But each cat toy costs $4 to make, which means cat toys are going to be $6 profit. Okay, so that's our first equation. Our one equation is going to be the profit that she makes. So if she sells for $10 and is $4 to make, she makes $6 per cat toy. Similarly, the cat beds sell for $25, but she has to pay $15 to make them, which means her profit is going to be $10 per cat bed. Now, when she sold cat toys and sold cat beds, she made a profit of $480. So that's going to be our first equation. Also, she sold a total of 50 items. So that's going to be our second equation. How many items did she sell? Well, X, the toys, plus Y, the beds, were 50. So I have a system of equations here, and let me rewrite them out and make it look a little prettier. In the last video that I did, where I had a similar problem, I used elimination. So here, let me use substitution just to switch it up a bit. Okay, I'm going to take the bottom equation and solve it for x. Why not? If I take the bottom equation and solve it for x by subtracting y from both sides, I get x equals 50 minus y. I take that equation and replace the x up here with 50 minus y. So let me write that out. 6 times, instead of x, 50 minus y, close parentheses, plus 10y equals 480. 6 times 50 is 300, distributive property. 6 times negative y is negative 6y. Drop down the plus 10y. Drop down the equal sign. Drop down the 480. These two combine to make 4y. So I have 300 plus 4y equals 480. I'm running out of space. Let's subtract 300 from both sides. Come up here, and that gets us 4y equals 180. Divide everything by 4, divide everything by 4, and I'm pretty sure that that's going to be 45. So y is 45. What don't I have? I don't have x, but you know what? I solved for x down here. That's the nice thing about substitution is once you get one variable, the other variable is pretty easy to find. So you take x equals, you replace y with 45, and 50 minus 45 is going to be 5. Now, x is 5, y is 45. My answer is not going to be some point. My answer is going to be words because this is a word problem. What did x stand for here? Cat toys. So Emma sold 5 cat toys, and y represented cat beds, so 45 cat beds. Okay, so not the easiest problems. You're always coming up with two equations. Usually one equation is going to be your total amount. The other equation is going to be some type of value. This one involved a little bit more because I was given more numbers and I was dealing with profit. And profit is how much you sell minus the cost. So I had to do a little bit more than usual. But tricky problem. We did it. We got it right. Emily and Sarah are participating in a charity walk. Emily starts walking from her house at 8 a.m. at a speed of 4 miles an hour. Sarah starts walking from the same house at 9 a.m. at a speed of 6 miles an hour. At what time will Sarah catch up to Emily? So we are looking at distance equals rate times time, and we're looking at two different people. You've got Emily, and you've got Sarah. Okay, Sarah. That's a song. Now, Emily, we don't know her distance. Okay, so we'll just keep D for distance. We know her rate is going to be 4 miles an hour, right? Yep. And what we also know is her time is since she left at 8 a.m. and Sarah left at 9 a.m., if we say that Sarah's time is t, she has 1 hour on her. So we'll say 1 plus t. Okay? Now Emily, her distance, we don't know. We know that her rate is 6 miles an hour, and her t is just regular. Okay? Emily has an hour on her because she started an hour earlier. That's where we get the 1 plus t. Now, if I were you, I would set these two, this is, system of equations. And since D equals this and D equals that, then we could say this equals that. So how about 4 parentheses 1 plus t equals 6t. I don't need to keep that in parentheses. I'll leave it right there. Okay? Distribute. 4 times 1 is 4. 4 times t is 4t. That equals 6t. We can subtract 6 from both sides. I always like getting rid of the guy on the right, and a lot of people will be like, no, I'm not going to do it that way. This is the way I do it, and you're going to watch me. Okay, so that's how we get it. Subtract 4 from both sides. I'm running out of space, so up here I'll write out negative 2t equals negative 4. Divide both sides by negative 2, divide both sides by negative 2, and t equals 2. So t represented Sarah's time. Sarah left at 9 a.m. So 2 hours after 9 a.m. is going to be 11 a.m., and that's when she caught up. Tricky problem, very strange. Also as strange as me trying to draw a circle and not completing it, but that's how you do it. All right, graph the solution. What we have here is what's called a system of inequalities. What you do is you graph each inequality one at a time, and you shade each side one at a time and find out where the two shadings meet. Wherever the two shadings meet is going to be your solution. So let's take a look at each of these. All right, these are already both slope-intercept forms. So remember, slope-intercept form is y equals mx plus b. So when I compare this first one and that first one right there, the number in front of x is my slope. So my slope is going to be negative 1 or negative 1 over 1. And my y-intercept is going to be negative 2. So let's graph that first. Okay, now this is a negative slope, but I always start out at negative 2. So I'm going to put a dot at negative 2. My slope is negative up 1, left 1, up 1, left 1, and I make as many dots as I can. So far, graphing this is no different than graphing a regular equation up until now. Now, my symbol here is less than or equal to, which means I draw a solid line. So, fortunately, I have a solid line up here waiting for me. Let's draw that out. Now, the reason why it's a solid line is the fact that it's or equal to, and or equal to means we include the line. So, or equal to. I'm not done yet with this problem though. I have to shade a side. So since it's less than or equal to, I'm going to shade the bottom side below the line like this. Okay, now this is just one of my lines. Clearly I'm not done. This is just one of my lines, but right now I've shaded one of my sides. So according to this, any of these points are going to be a solution to that top equation right here. But I need both equations graphed to find my final solution. So let's graph U. Let's focus on U in blue. Okay. This one, my slope is going to be negative 5. So m is negative 5. I'll write 5 over 1 to keep it as rise over run. And my y-intercept is going to be positive 2. Start out at positive 2. This is a negative slope, so I'm going to go up 1, 2, 3, 4, 5. I can't, so I'll go down 1, 2, 3, 4, 5, right 1, put a dot there. There's my dots overlap, and then I can't do any more. Again, I need to focus on the fact that I have a greater than or equal to symbol, which means when I graph this, it's again a solid line. Okay, so again, solid because I'm including the line because it's or equal to. Now this has me greater than, which means I'm graphing above this line. So let me shade above this line. It's going to look like this. And what's going to happen once I start shading a little bit more and once I get to the bottom is we're going to see where my blue and my yellow meet. And the part that my blue and yellow meet and create that little green area that you can barely see right there, that is going to be the solution to my system of linear equations. Linear inequalities. What I like to do with these is I like to label it R for region, like that. But this is my area that gives me all of the possible solutions for both of these. When you graph a system of equations, you are trying to find an area where both shadings meet. And in this case, both shadings meet in this little area down here. And if this were to keep going and that were to keep going, you would have more. But I can pick a point like 2, negative 5. Okay, 2, negative 5 is a point right there. That's in my green area. If I were to label 2x and negative 5y and plug them in for both of these, that will work. Along with any of these points down here, those will all work. Graph the solution to this system of inequalities. All right, I have two inequalities. I'm going to graph them both, which involves shading, me being careful with lines, and finding out where both shadings meet. So let's take a look at this first guy right here. This is x is less than or equal to -3. This is not standard y equals mx plus b form. This is just x and a number. When you have just x and a number, your point and your line is going to be a line that's vertical going through -3. So I'll put a dot right here at -3, and then I'll come over here. I will draw a vertical line going through -3. Now, before I just willy-nilly draw a line, there's two things that I have to notice. It's less than or equal to, which means the line that I'm going to draw is going to be a solid line because I'm allowed to include the line. That's what the or equal to part means. Now what I have to do is determine which side I shade. Since this is less than -3, I'm going to shade to the left of -3 like so. So this blue shading is the stuff that's going to be true for that top equation. Any point in this area is going to be a true statement for the phrase x is less than or equal to -3. Now I have my other equation, and my other equation is in slope-intercept form. So here I could say that my slope, let's get a nice thin one, my slope is going to be 5/3, positive 5/3 is going to look like this, and my y-intercept is going to be 2. So we'll start out at 2. We'll go up 5, right 3, so up 1, 2, 3, 4, I can't do it. Down 1, 2, 3, 4, 5, left 1, 2, 3, put a dot, down 1, 2, 3, I'm out of space. Now here I have less than, not less than or equal to, which means I need to turn my line into a dashed line. So I connect the dots like this, like so. But I'm not done yet. See, what I have to do is now that I have my line, I have to shade to the underneath part of it because y is less than that. So I'm going to shade a lot of this graph, but only a teensy part is going to end up in my final answer. So shading, shading, shading. And what's going to happen is as I shade all of this and all the stuff that's yellow is going to be stuff that's true for the bottom equation. Okay, true for the bottom equation until I hit this part. Now that little chunk that's barely green, you can barely see that it's green, that chunk that the blue and the yellow overlap is going to be my final answer because that's where the inequalities meet. Okay, so I always like to label that R because R. And what that means is anything in this area is going to be a point that makes both of these true. So some random point like -4, -6 would be a point in that area. -4, -6 would live in this green area if that were to keep going. And what that would mean is if I were to plug in -4, -6 into the top equation and -4, -6 into the bottom equation, it would work for both of them. So blue only works for the top, yellow only works for the bottom, and green here, the R, works for both. Graph the solution to the system of inequalities. Well, these are both a train wreck because neither of them are solved for y. So let's solve them for y. Let me take this one equation at a time. I'll take the top equation and then graph it. 3x plus 2y is greater than or equal to -2. In order for me to get this into slope-intercept form, my first step is to subtract 3x from both sides. That cancels out. Drop down the 2y. Now, these two don't combine. -2 and -3x do not combine, but I'm going to write them out with the -3x first because I want to make it look like slope-intercept form. Divide both sides by 2 has you dividing literally everything by 2 and simplifying when you can. So y is greater than or equal to -3 over 2x. -2 over +2 is going to be -1. That's my first equation. So my slope is -3 over 2, and my y-intercept is -1. Start out at -1. And then since this is a negative slope, we're going to go up 1, 2, 3, left 1, 2, up 1, 2, 3, left 1, 2, and put dots until you can't anymore. I can also go down 1, 2, 3, right 1, 2. Now, before we continue, we have to notice what our symbol is. Our symbol is a greater than or equal to, which means our line is going to be solid. So we'll pick a solid line, draw a line through it, and since it's greater than or equal to, we are going to shade the side greater than or equal to that. So here we go. This is me shading. Okay? So that's equation number 1 after we solved it for y and then got y all by itself graphed, correct line, shading, bada bing. Now let's do the second line. So what we have to do with this bottom one is we're going to rewrite it like we did here. Let me give myself a little bit more space. I hate it when I do that. Switching from markers to markers. X plus 2y is less than or equal to 2. Same exact process. Get rid of the x that's floating around by subtracting it from both sides like so. Drop down the 2y. Drop down the less than or equal to. Drop down the negative x and the positive 2 in that order so it looks like slope-intercept form. Now, let's divide everything by 2. Y is less than or equal to negative invisible 1 over 2, so negative 1 over 2, drop down the x, and positive 2 over 2 is 1. Notice how in none of these we had to worry about like flipping signs, which is good, because I don't want to have to do that. I don't have to deal with that. I didn't have to. Slope-intercept form, that's my slope. That's my y-intercept. So I'm going to put a dot at 1 here. That is a negative slope and go up 1 over 2, up 1 over 2. So I have my overlap right there, up 1 over 2. I'm out of space, so I can go down 1, right 2, down 1, right 2. Now, just like last time, this is a less than or equal to. And what I mean by last time is the or equal to part. Because what that means is I only have to worry about a solid line. Again, I don't have to worry about dashing my line because it's or equal to. Now what I have to focus here on this line is the fact that it's less than. So I'm shading underneath the line. Underneath the line. So let's just make sure I get the right one. Shading underneath, shading underneath. Now everything here in blue and only blue is a true statement for the bottom equation. Once I mix my colors and get this green area, that's going to be my final solution. That solution is where both shadings meet. And my final answer is going to be where both shadings meet. So what I like to do is I like to call it R for region. But all of these points in this area right here, points like 4, negative 3, points like 1, 0, even the points that are on the line, like 0, negative 1, and 0, positive 1, if I were to take any of these points and plug them into both of these equations, it will be true for both. And that's how you graph a solution to a system of linear inequalities.